Hey guys, this is Mr. C, and today we're going to talk about some factoring methods for quadratic expressions. So I've got two different methods I'm going to show you, and hopefully this will kind of help you out when you're factoring these quadratics. They're a little tougher to factor. And so the first one I have is going to be, I'm going to start out actually by not just giving you the quadratic, I'm going to give you the answer. X minus 4 times 2x plus 9, which you're never going to be given at the very start, but this is how you can build your own problems and you can practice it yourself. If you multiply this out using either FOIL or distributive property or the box method, you get 2x squared. You get a 9x and a negative 8x. Well, that would give you a 1x in the middle. Okay, then you've got 9 times 4, which is going to be, and it's negative 36. Okay, so there's our quadratic expression. Now, we're going to use first the slip and slide method. The slip and slide method is really cool, and the proof of this is not very complicated. I might show you in another video. I'm not going to show you it here. You can Google it online. It's called slip and slide, factoring quadratics. There'll probably be videos and all that kind of stuff. So we take the 2 and we move it back with the 36. And when we move it back, we're going to multiply. So we're actually physically going to move this back with the 36. And we're going to get x squared plus x, and then minus 36 times 2, which is going to be 72. Now that is obviously different from the original problem, right? So we're going to have to still get back here when we get done. We're going to have to do something to do that. So now what this does is it makes our hard problem easy, because by now we should be able to solve these types of quadratic expressions easily, because these are monic and this is non-monic. So what two numbers multiply to give 72, and the difference is 1. And you might have to think about this, especially when that number's fairly large. I think maybe 9 and 8, because 9 times 8 is 72 and the difference is 1. But sometimes it'll take a little bit longer. Sometimes you'll get it, right away. So what we do is we go ahead and write those two factors down. But I'm going to leave a space in front of the x's. X plus 9. And I'm going to leave a little space here. X minus 8. And the reason why we leave the space here is because this made it easier, but now we have to pay the price by putting that 2 back in front of these x's. And that's the slide part. The slip was slipping the 2 back. The slide is sliding it in here and then in here when you get done. Don't just leave this as your final answer, because that is not the same thing as this, obviously. So we're going to put the 2 back in. When you put that 2 back in, you're going to introduce, by doing this, some extra numbers here. And so if you look at these two factors, 2 and 9 have nothing in common other than 1. So we can't really do anything with that. But that 2 and that 8, we can divide both those by 2. And so I'm going to divide both of these numbers by 2. And part of this process is getting rid of that extra number you put in there in this process. So the 2x plus 9 stays. But this is really going to be 1x minus 4. Okay, so look what I got. I have this answer here, and it's equivalent to this one because all I did was switch the factors up, but that's the commutative property of multiplication allows me to do that. It's still the same expression. When I multiply this back out, I'm still going to get this back, and I am done. And by the way, whenever you get an answer here, if you didn't do it this way at the very beginning where you knew the answer, you might want to multiply these back out and distribute or expand it and make sure you get the original quadratic back. So that's done. That's method number 1. To me, that's a very, very handy method. This is method number 2. I'm actually going to use the quadratic formula to get my 2 factors. So what I'm going to do is I'm going to treat this like it was an equation, even though it's not. 2x squared plus x minus 36 is equal to 0. Okay? Again, not the same thing as this. However, it's very close. We could actually call this an auxiliary equation. And I'm going to use the quadratic formula and see what the two solutions are going to be. So using the quadratic formula, We have an a value of 2. We have a b value of 1. And we have a c value of negative 36. So we're going to plug that into our quadratic formula. All right. Hopefully we all remember that. It's going to be opposite b. So opposite 1 plus or minus square root b squared. 1 squared is 1 minus 4 times a, which is 2, times c, which is negative 36. All right. And again, I'm going to make this look good. So I always have to use the straight edge because otherwise I'm going to mess that up. All over 2 times a. And 2 times 2. Okay, now I'm going to simplify this. When I simplify this, I'm going to kind of skip a few steps in here, but everything that I'm going to skip you can do yourself easily. X is going to be equal to negative 1 plus or minus the square root of. Now, 4 times 2 times 36 is really 288. These two negatives are going to cancel out and add to the 1. And it's really all of this, we call that the discriminant. All of that is going to be 289 when you get done. And the reason why I'm skipping these steps is because I don't have enough room on this whiteboard to fit it all in here. But we can do this easily on a piece of scratch paper. So we have the 289 over here. And all of that is over 2 times 2, which is 4. And now you see why I have to use a straight edge, because I can never make that straight. So 289 is a perfect square. And as a matter of fact, if your expression right here was factorable, then that should be a perfect square right there. And the square root of 289 happens to be 17. So now we have x is equal to negative 1 plus or minus 17 over 4. Well, that's going to give me 2 solutions. One solution is going to be x is equal to negative 1 plus 17 over 4. Negative 1 plus 17 is really 16, right? So 16 over 4 equals, and then 16 divided by 4 is 4. Now the cool thing is x is equal to 4. To make that into a factor, you'd move the 4 over, and that would actually be x minus 4. Now, is that one of our original factors? It sure looks like it right there. Let's take a look at the second solution. X is equal to negative 1 minus 17 over 4 equals. Negative 1 minus 17 is negative 18 over 4. These are both even, so you can take a 2 out of both those. And actually, we're looking at negative 9 over 2. Well, to turn this back into a factor, 2x opposite 9, 2x plus 9. Now, was that one of our original factors? And it sure looks like it. And we have our 2 factors right there. And we didn't even use any factoring techniques. All we used was a quadratic formula. So why am I showing you these both methods? This one looks a little longer. This one looks shorter. The reason why is because some people really don't like factoring at all. And they really do like the quadratic formula. Well, this is very easy to do because this is all a computation. Once you get done with this quadratic formula, it goes really quick. When you get used to it, you get your 2 factors back. Here, you're going to have to remember how to do this process and, over and over again. So I'm presenting you with 2 different ways to do this. You can pick one, you can pick both of them if you want to. And it's good practice. And so that's our example number 1. Let's do example number 2. Example number 2, we're going to start out with 4x plus 3 and 5x plus 7. Okay, slightly more complicated. If you multiply this out or expand it, you're going to get 20x squared. Okay, plus 28 and plus another 15 should give you 43x. And then 7 times 3 is 21. So plus 21. So there's our quadratic. All right. Again, we're going to slip the 20 back with the 21. And I'll show a line. I wish I had some colored markers, but I don't at the moment. And so we're going to multiply 20 times 21. So we have x squared plus 43x, and then you have 420. Okay, that 420 right there, 420 looks pretty complicated. There's a lot of factors that go into that. So we're going to have to figure out what two numbers multiply to give 420, and the sum is 43. And again, you might have to sit there for a while until you figure out the two numbers, because 420 has a lot of different factors. However, we can partition those factors into two groups. And I'm going to go ahead and tell you what they are, just to save a little bit of time. And they are going to be 28 and 15. And I'm trying not to smudge this because I'm left-handed. I won't say unfortunately because I like being left-handed, but plus 15 over here. Okay, so now I left my blank in front, and what goes in the blank? 20. So I'm gonna put my 20 here, and I'm gonna put my 20 here. Okay, so in both of these factors now, I'm gonna have to take something out. These two numbers, 20 and 28, are both divisible by 4. So I can divide a 4 out of those. And you always want to divide out the maximum number, the greatest common factor of these two numbers. Here, 20 and 15, it looks like a 5 can come out of those. So divide by 5. Now, if I'm looking at this, I'm finding something curious. 4 and 5 just happen to be that number and that number right there. As a matter of fact, that's how it's going to be. These two numbers that you're dividing out are going to be the original two numbers here. So here it comes. 20 divided by 4 is 5. 28 divided by 4 is 7. So 5x plus 7. The second one, divide by 5, divide by 5. So it should be 4x plus 3. And that is it. That's the exact same thing I had at the very beginning, except my factors are switched. Now, why did my factors get switched? They got switched because up here, I decided to put the 28 there and the 15 there. I could have switched them, and then my two factors would have been the exact same thing up here. But I decided to put the 28 there and the 15 there. It doesn't really matter because the commutative property of multiplication will give me the same result here and here. So it's factored. To me, that's a very simple thing. The only thing with this method that gets tough is figuring out how to factor this quadratic right there. But if that's easy for you, then you've got it made. All right, so let's take a look at the quadratic formula and see how that works. So over here, this is our quadratic we're working with. 20x squared plus 43x plus 420. Okay, now I have an a value of 20. I have a b value of 43. And I have a c value of 420. Those numbers are pretty big, so you're going to have a calculator handy when you do this, probably. So here we go. X is equal to opposite b plus or minus square root of b squared minus 4 times 20a times 420, which is c. And I ran out of room a little bit, but that's okay. So let's make that look decent. All over 2a. Two times 20. Okay. So now we have a lot of stuff going on here. 4 times 20 times 420. I'm gonna actually write this step out, I think, because the numbers are getting a little too big. 43 plus or minus square root. Okay, 43 squared happens to be 1,849. Okay, minus 4 times 20 times 420. Multiply all three of those numbers and you get 1,680. All right. It's still minus because neither of those numbers were negative. Okay, so that's all under the square root here. And we're going to divide that by 2 times 20, which is 40. Okay, simplification. 1849 take away 1680 happens to be 169. If you take the square root of 169, it's going to be 13. So to save a little bit of room here, which I really hate skipping steps, but unfortunately sometimes I have to do that. That's all going to shake out to be 13. And all of that is over 40. Okay, so let's get our two solutions here. I'm going to actually move back over here a little bit so I have some room. So our first solution is negative 43 plus 13 over 40. Negative 43 plus 13 is negative 30. And negative 30 over 40 is going to reduce all the way down to negative 3/4. That's going to actually give us the factor 4x plus 3. Okay, the second one, I should really number these. The second one, x is equal to negative 43 minus 13 over 40. Negative 43 minus 13 is negative 56. And this is why you have to know how to simplify fractions. All right. Negative 56 over 40. 8 goes into 56 7 times. 8 goes into 40 5 times. So we're going to get negative 7/5. All right. So this factor is going to be 5x plus 7. Okay, did we get the same two factors back that we need? Well, it looks like it here. 4x plus 3, 5x plus 7. All right, guys, hope this helps. Remember to like and share, and we'll be seeing you soon. Bye, guys.